Polatis is the leading manufacturer of all optical switches and adds software-defined connectivity wherever you need to add flexibility to an optical network. Networks are facing a challenge from the fact that our appetite for data is still doubling maybe every 12 to 18 months. To be able to address that challenge, we need to find new ways and new network architectures to cope with those volumes of data. Polatis optical switches help to address this problem by making transparent connections between data sources without converting light into electricity and back again. And this allows us to be considerably more energy efficient and increase resource utilization. One of the things that we found over the years is that by engaging with academia, we're able to multiply the effectiveness of our small engineering team by becoming aware of new techniques and being able to apply them earlier than we would otherwise do.
I'm Georgios Zervas. I'm a professor of electronic and electrical engineering, and I lead a research team in optical network systems for cloud data centers and high-performance computing. So currently, myself and my PhD student, Zach Shapka, we're working closely with Polatis to develop novel machine learning methods that can significantly improve the performance and the manufacturing processes of an optical switch like the one developed by Polatis. We are undergoing a number of fascinating experiments where we use optoelectronic devices based on ultra-wideband lasers and semiconductor optical amplifiers, which we control them using machine learning methods in order to switch them across a broad spectrum of colors of light in less than a billionth of a second. Based on this technology and the network architectures that combine lasers, modulators, SOA gates and passive components, then we form systems that will connect between different servers in order to create a data center experimental environment.
So working with UCL has helped us to become aware of techniques that we wouldn't otherwise know about and would certainly not have the time ourselves as a relatively limited engineering team to become expert in. And so what we've been able to do with this project, with Zach in particular, is take a relatively new technique, that of machine learning, and apply it to our own products with very encouraging results. We will benefit from the results of Zach's project by having a more efficient manufacturing process and incrementally improving our production yields.
Yeah, the collaboration with industry I see fundamental to linking theoretical research to practical research which can materialize and change the world. Essentially, there is a process between theory, experiments, and actually exploitation, which is the link with industry that help this transition.